All right, so for a couple of videos now, we'll be looking at OpenCV, and we'll try to create some projects with OpenCV, and some will be exclusively using OpenCV, others will be we'll use other libraries, interesting libraries too. So don't forget to come back for more. What's OpenCV? What's OpenCV itself? So OpenCV means open source computer visionary library. Open source computer visionary library, and it's one of the most popular, if not the most important, because personally I think it's the most important library for computer vision. It virtually allows us to process images, videos, to detect objects, and just basically the holy grail, the holy grail of working with anything images, everything images, and videos. OpenCV is technically the holy grail. So what makes it popular and so widely loved among data scientists? I've yet to see a computer vision scientist that does not like OpenCV. I've not seen one yet. So okay, what makes it so interesting? First, it allows for comprehensive image processing, right? OpenCV supports a huge range of functions that can analyze images, making it very easy to do the pick from the shelf and drop. You pick the function, use it and drop it. It's very friendly, just as easy as using pandas, for those of you that know how to use pandas. Also, real-time video processing. It allows video capture and real-time processing, including streaming, including working with recorded videos. So it allows for, it's very versatile, especially when it comes to processing of videos as well as images. This is actually one of the reasons why I love OpenCV. It works on multiple platforms. It is it's very good cross platform library, right? It works on Windows, works on Linux, used it on Mac. Recently, it has been increasingly used with mobile OS, just such as Android. So it can be used across several platforms. Then, of course, it's also open source, most open, free to use, just like most Python libraries. And please take note that it's not only Python that we can use. Python is not the only language which OpenCV has been used. Of course, C++, Java, but for the sake of our tutorials, to be using Python. So of course, it's free to use and it has a very large community. You cannot be lost. Wherever you have any problem, you can simply run online and you see help. So it's the community is great, and it's open source. So that's that. All right, so let's get started with OpenCV. Now, first of all, how do we install OpenCV? So I'll just leave here first. So let me just create a new Python file and just let me use this here, and then that's interesting. Okay. All right, so how do you install OpenCV? Very simple. Simply use the most basic installation, which is basically your pip install. right? Simply pip install OpenCV Python. Please take note, it's not just OpenCV, it's OpenCV Python because OpenCV has been integrated with the Python, so it's now OpenCV Python. So I have it already on my system, but this is basically the way you can um, get OpenCV. Plus, take note, unlike so many libraries, you may be confused. When you are importing OpenCV, you don't import OpenCV, right? Rather, what you import is CV2. But when you are making your installations, you use OpenCV Python, not OpenCV, OpenCV, all right, Python. So just as easy as that. Um, as at October 2025, which when this video is made, the latest version of OpenCV is 14.12.0.88. 14.12.0.88. Of course, whenever you are installing yours, you may get a more recent version of the library, right? But I think any version works. I don't think I've used any version that has really had problem. And even the older versions still works well, at least for most of the basic libraries. So what are these basic operators you can use with OpenCV? The import CV2, right? Of course, you've seen me use that. That is used for importing OpenCV. All right. We also have the InRead, which we'll use shortly. Is used to read images or videos. And we also have the InShow. The InShow is used to show the video or show the image. And then we have the InWrite, which is we can use to save a processed image to your local device. All right. So let's start. Let's do a very simple. Let's play with OpenCV. So for this, I'm using Visual Studio Code. So yeah, let's go back to this. All right. So first of all, let's get OpenCV. Then I think I have a beautiful picture here. You can play with this picture. I think I'll just this picture for you to see. I think I have it here. Let's see. I'll show you the best picture in the world. So I think we can just play around with this. All right. So yeah, just like I said, we're going to play around with this picture. Right. You can see the best picture in the world. Of a good friend here, very good, a good family friend, and a family from a family friend, and the sweetest trophy in the world. So that's that. All right, so let's just try and get this and see if we can view it. So what do we do? First of all, we import CV2, which is importing OpenCV. Then we have IMG CV2. Bless you. Read. So we have the InRead here. Remember, what did I say? InRead is used for reading. So this is going to get this. So we have balloon, the address PNG. Then we have this as the next what we add here will just tell us how we are going to import the picture. You can see that picture was in colored. If you want it to be unchanged, you can simply put -1 here to show that you want it to be unchanged. We want it to be unchanged. However, if you want it to be in grayscale, almost like black and white, you can put 0 here. And then we want it colored, you use 1. So those are the basic attributes you can use to make our imports. So for now, let's just put 0 here. And then, of course, there's something else we want to do. We want to show our image. So we have cv2 dot show. Of course, what this will do is this is going to bring a window, a pop-up window, which you can use to display the picture or video or whatever. So first of all, we need to title the window. So let's just call all right. Then we now import what we want to import, which it will be our image. This is what we want to show. Then of course, we will need to know how long, when the Windows window pops up, how long do we want the window to stay before it goes off, right? It's a simple trick. How long do I want the window to pop up before it goes off? So you can say cv2 dot wait key. Wait key means how long do I want it to stay, right? Or it can be used to say what key should I press? Once I press that key, the window will go off. Those are some of the things. That's why it's called wait key. But if then I'm going to put an ASCII. But if I want to know how long it wants to wait, I can still use, then I'll put the time here in milliseconds, right? If I want it to be there infinitely, right, until I use the X to close the window, I can simply put 0 here. So what does this do? This just infinitely waits. All right. So that being said, we are done. But good practice says that we need to, whenever we close, we need to destroy all windows created by this. It's just good practice. If you want to tick enter before, you'll be used to this. So we'll destroy all windows. All right. Once it's done, once we've seen what we needed to see. So let's just run this. All right, you can see this is our brother, a good friend in OpenScale, right? So this is it. That's very simple, very basic, the simplest code you can ever get. So yes, if you've done that, then you are officially an expert in using OpenCV. All right, so we can simply close this here. Great. So that being done, now that that's been done, let's see how we can do more tasks with OpenCV. We've shown how to display an image and write it on this. To write it on this, you simply use imwrite, as I had explained earlier. So for our next task, we'll quickly see how we can resize an image in OpenCV. Another very simple project. So let's just go back here. So now the size of this image, you want to reduce it. So first of all, let's just keep this, but let's remove this. Let's still know that we've read this. Let's remove this because you don't want to show this. So let's just remove this for now. Let's see, use this our image. Let's make it let's just keep the normal color. Then remember, when we are talking about resizing an image, there are two things you may want to do. We have rescaling, we have upsizing, and we also have downsizing. We have upsizing and we also have downsizing. So first let's get the original size of our image. How do we do that? We use shape, the conventional shape that we use every day in our pandas. So we can say that our height and then our width is equal to image.shape, right? So we just get the first two, right? The first two features of this will give you the height and the width. But let me just print everything for you to see. So let me just take this out. All right, you can see this is 524 by 524. Right, we just need these two. We just need these two. So we'll just take the first two. You can simply say whatever H W. We don't need this. So let me just take this away. Right. So now, what if I want to upsize, right? I want to upsize. We could say that our up width. Let me say I want to half it. I can say that half, right? Half of my height and half of our width will be equal to this divided by 2 and this divided by 2. All right. Is there any? Can we get any other heights? What if we want it to be a specific width? Let's say 300 by 300. We can say we just call it resized. You don't need to write everything. Side ish and resized W is h over 2 and w over 2. So this will be, say I want 300 and by 300. All right, beautiful. So what if I want it to be double enlarged, right? So let me say half. I want it to be double. So that means let me just take this again. Double and double will be equal to this should be times 2 and times 2. Beautiful, great. So that being done, so let's just set our titles. So the first one is we just have an original, then we have half, then we have resized, and then we have double. All right. So some errors and this. So that being said, yes. So we will have that our half noun be equal to cv2 dot resize. When we have resize, what do we put here? First of all, the image we're looking for, which is this. Then we will now have the new height and the width, which in this case will have h and have w. Then we need to put the method. What method? Sorry, this should. What interpolation method do we need to use in resizing? There are several interpolation methods for resizing. So what interpolation method will we use? So let's try. Shortly, I'll show you several interpolation methods. There's one called I love using. Did I get this interpolation? Yes. Linear interpolation. Right? There are several interpolations. We have Gaussian. There are several of them. I'll show you some of them shortly. All right. So it needs to know which of these. So we have CV2 dots. All right. The linear interpolation. So this is for half. All right, so this is the next one will be, let's say, resize h and resize w. All right, so this is resized. All right, so you have another one here, which is double. So this will be doubled, double H, and doubled double W. Interpolation is basically used to decide the pixel colors when an image is resized, right? What pixel color we'll be looking at when your image is resized, and there are several. We have the inter area. These are the popular ones, but there are more. You have the inter area. We have the interlinear, which you just used. We have the intercubic, and we have the internearest. So the question is, when do we use this? So most times we use the inter area when we are shrinking an image, right? So that means that when we go here, we should have been using the, yes, here we are shrinking the image. Here we are also shrinking the image. All right. So when do we use the intercubic? We use the intercubic, even though it's slower, when we are enlarging an image and we need very good quality. We use the interlinear, right? Generally, when we are, it's more like a general resizing, generally for resizing. We use the internearest, of course, when we want to do fast resizing, even though the quality here will reduce. So let's just change one to internearest and change one to inter area and see how our result will look like. So let's change this. So internearest, inter area. My computer has been a bit buggy today. All right, and then change this to internearest. All right, right, so that's fine. Okay, so let's see how we can, so what are our images, and then let's see um, how we can visualize this. So we have the original, we have the smaller, we have resized, and then we have enlarged. All right, no, not enlarged. I think I called it doubled. All right, so we have the original here. All right, so that being done, I think I'll just call it img. Okay, so that being done, let's so we're going to be printing all of them, displaying all of them. We will be displaying all of them. So we have this as so of course, those of you that have known how to use subplot before, so we need to import our matplotlib. Of course, you know what matplotlib does. Matplotlib is used for conventional plotting in Python. So we have this to subplots, then we have this as 2, we have 2 by 2, and then we have I plus 1 here. So we have so okay, then so what will be the title? So we have title. Inshow, of course, the inshow, our conventional inshow. So CV2. Then, of course, the CV2 normally processes its image in BGR, so we have to change it back to RGB. I'll be discussing that more as we continue with more projects. Please don't forget to come back. All right, so we have BG2 to BGR to RGB. All right. All right. Hope everything has, all the brackets have been covered. All right, beautiful. So that being said, we can plot. Let's blt.axis. I don't need to see the axis, so let me just off it. For all of us, those of us that know how to use Matplotlib, we need the use of this. I don't need the axis, so let me just take this off. Off. Yes. Then of course let's just keep it tight layer so it will look good. All right, and then of course finally PL to just show. So hopefully this, yeah. But, but before we run this, let's make some changes. So of course, have that this will be um, because this may be a float. Let's just assume that does give us a float. So just add an int. Whatever it gives us, will float to an int. Then we're resizing this, so let's just make this 250 so it will be revealing that is smaller, or 240, whatever. So we are doubling this. Let's just make this by 3 so that it will look more revealing. All right, so let me just save that and then let's run this and see how it goes. All right, you can see this has been resized. This original, this is half. This is not too revealing, so let me make it. Let me just make this 10 so that it will look very obvious. It's not very obvious now. So yeah. Yeah. Okay. To make this 4. All right. I think this is a bit more. It's more obvious now. Of course, you can see the iteration, the quality here. You can see the size here. And then of course you can see this and this. Yeah. Yeah. So let's try that. So that's that about resize. It's very simple function. Very simple function. All right. So that has been done. So the next thing we'll look at is how we can add shapes and images to our text. So we'll still use the same image. We'll still use the same image. However, but we do another task with that. But that will be, you can keep these shots.